Welcome back, students. This is the Q&A session 10 from the playlist of moving charges and magnetism. The topic is about SAVART law, and we have already discussed about this law in the previous session, that is in the session number 9. So based on the previous session, I have taken this question for this session, and a very similar question is also available in the NCERT book. This question is somewhat manipulated by me, and so here the question is, a current carrying element of length 1 centimeter is placed at the origin along the x-axis. So this is the origin, and this is the current carrying element, and it is placed at the origin as shown in this figure. The current which is flowing through this element is 10 ampere. That is, the current which is flowing through this current element is 10 ampere. So we have to find the magnitude of the magnetic field at a point which is 0.5 meters from the origin towards the positive x-axis, with the displacement vector making an angle of 30 degree with the x-axis. With the displacement vector inclined to, it means inclined to the x-axis at an angle of 30 degree. So here the OP is the displacement vector, and this is equal to 0.5 meter. And so in the previous session we have already studied that the magnitude of the magnetic field at a point is given by mu naught upon 4 pi I dl sin theta divided by r square. So in this case you don't have to think too much, because all the parameters are already given in this question. So the magnitude of this of the magnetic field at the point which is 0.5 meter from this origin towards the positive x-axis and inclined to it at an angle of 30 degree. This is equal to, now mu naught upon 4 pi is a constant whose value is equal to 10 to the power minus 7. It's the unit is a Tesla meter per ampere, and dl is given, is the length of the current carrying element is 1 centimeter. So I will be just converting into meter, which is equal to 1 by 100 meter into sin theta. Now theta is the angle between this displacement vector and this current carrying element. So here theta will be equal to 30 degree. So sin 30 is equal to half divided by r square. R is equal to 0.5 meter. So this will be equal to 0.5 whole square. So finally, here I will be getting the answer as, this is 10 to the power minus 7, and this will be equal to 10 to the power minus 9 into this 1 by 2 will, this 2 will come in the denominator, and this will be equal to 20, this will be equal to, sorry, this 0.5 is equal to 1 by 2, so 1 by 2 whole square will be equal to 1 by 2 into 1 by 2. So this is equal to 10 to the power minus 9, and this will get cancelled out into 2 Tesla. So it implies that dB is equal to 2 into 10 to the power minus 9 Tesla. So this is the magnitude of the magnetic field at this point P due to this current carrying element which is placed at the origin. This is the answer, that is 2 into 10 to the power minus 9 Tesla. So this was a very easy question. The only the purpose of taking this question was to just acquaint you with the application of this formula, that is this formula, how this formula is basically used in solving the simple numerical problems. So in the next session I will be coming up with a different topic from the same chapter, that is moving charges and magnetism. So till then, have a nice day. Bye.